Let's start with section 15.8, Stokes theorem. So the first question here, find the curl of the vector field F. So I, J, K, the derivative with respect to the X, the derivative with respect to the Y, and the Z. So for the I, is going to be the derivative with respect to the Y, so it's going to be XZ minus the derivative with respect to the Z is going to be E to the Z. For the J, don't forget the negative sign. The derivative with respect to the X, so it's going to be YZ minus the derivative with respect to the Z is going to be -1. So you have minus -1 is going to be plus. And distribute the negative sign is going to be minus. The derivative for the K, the derivative with respect for the K, the derivative with respect to the X is going to be 0. The derivative with respect to the Y is going to be 9. So this is the curl is going to be XZ minus E to the Z minus YZ minus 1 and -9. So we're gonna plug in here XZ minus E to the Z and E to, the second one is going to be -YZ minus 1 and is going to be -9. That's it for the first one. For the second one, we're going to do exactly the same thing. Find the curl. We have the function x sine y, I minus y cosine x to the j, and 4yz squared to the k. So we're going to do the same thing. Here is x sine y, -y cosine x, 4yz squared. So now for the I is going to be the derivative for the y, so it's going to be 4z squared, and the derivative for the z is going to be 0. For the j, there is negative sign. The derivative with respect to the x, 0. The derivative with respect to the z, also 0. For the k, the derivative with respect to the x is going to be y, negative sign x, minus the derivative with respect to the y is going to be x cosine y. Combine these together, so it's going to be 4z squared is going to be, in fact, you can't combine, just distribute the negative sign. So it's going to be -y times negative sign. It's going to be y sine x minus x cosine y. So that's it for the second one. So we're just going to plug in as a vector form 4z squared and comma 0 and comma y sine x minus x cosine to the y. That's it. For number 3, we're going to use the Stokes theorem to evaluate the integral on the CFDR counterclockwise. So F here is our F, and the triangle with the vertex 9, 0, 0, 0, 9, 0, and 0, 0, 9. So let's check this example. So here's our f, 2y, 3z, and x, and the integral, the Stokes theorem, the integral f dr is the same thing, the double integral on s, the surface curl f, dot product with n ds, and the same thing on the r, curl f with the gradients of the function, gradients g dA. So here is our plane x plus y plus z equal 9. If you have a problem how to find this one, you have to go to the previous section. So here is our triangle. If you graph it, is going to be with the vertex, this is 0, 9, 0, and this is with the, this is 0, 0, 9, this is 0, 9, 0, and this is 9, 0, 0. So if I took to the XY plane, it's going to be, here is the X9, here is the Y9, the X is 9, and Y is going to be the line here is going to be Y equal 9 minus X. So we're going to assume that G is, we're going to move the 9 to the other side. So it's going to be X plus Y plus Z minus 9. That means the gradient of the G, the derivative with respect to the X, 1, the derivative with respect to the Y, 1, the derivative with respect to the Z is going to be 1. Curl of the F is going to be 2y, 3z, and x. So the derivative with respect to the x, for the I, the derivative with respect to the y is going to be 0. The derivative with respect to the z is going to be minus 3. For the j is going to be negative. The derivative with respect to the x is going to be negative 1. The derivative with respect to the z is going to be 0. For the k, the derivative with respect to the x is going to be 0 minus the derivative with respect to the y is going to be negative 2. So then now the curl f times the gradient of g dA is going to be the integral from 0 to 9, and from, this is for the x, from 0 to 9 minus x. For the y, negative 3, which is the curl of, times the gradients, which is 1, 1, 1, dy dx. Let's do the dot product here. It's going to be negative 3 plus negative 1 plus negative 2 dy dx. And it's going to be from 0 to 9, from 0 to 9 minus x, negative 6 dy dx. Then it's going to be from 0 to 9, negative 6y. We're going to do the integral for the y. So it's going to be negative 6y from 0 to 9 minus x. Plug in 9 minus x. And then it's going to be negative 54 because we're going to distribute here. Negative 54 plus 6x dx. So it's going to be negative 54x plus 6x squared over 2, which is going to be 3x squared. Plug in the 9, so it's going to be negative 54 times 9 plus 3 times 9 squared, and the result is going to be negative 243. 243. So for this one, I'm just going to plug in negative 243. That's it for number 3. We're going to do the same thing for number 4 and number 5. So we got right. For number 4 and 5, you're going to do the same thing. I'm not going to solve these two examples because you're going to get exactly the same thing with the same numbers. But if you look to example 6, it's exactly like number 5, but there is a note I have to mention that when they're telling you counterclockwise and just clockwise, there's no example here with the clockwise. So there is a little bit thing you have to check that. Here's the note. So the note says to convert this from the surface to the R, from S to the R, if it's clockwise, you can assume that G is going to be G of XY minus Z. But if they're telling you counterclockwise, you're going to say G equals Z minus G of XY. So this is important. So if you check on example 6, they're going to tell you counterclockwise. So I'm going to say, here's our function with x, y, z, and 4x, z, and y, and 4x, y. So z is equal to 25 minus x squared minus y squared, and z greater than 0. I'm going to start with z equals 0. That means z belongs to 0 and 25 minus x squared minus y squared, which is this one is the circle, 25 minus r squared, and r, because the radius is going to be 5, so it's going to be r belongs to 0 and 5, and the theta between 0 and 2 pi. So to find the curl of f, I'm going to write down these with I, j, k. The derivative for the I is going to be the derivative with respect to the y is going to be 4x, minus the derivative with respect to the z is going to be 0. For the j is going to be negative. The derivative with respect to the y, so it's going to be negative 4x, negative 4y, because the derivative with respect to the x, minus is going to be plus. The derivative with respect to the z is going to be 4x. And the derivative for the k, the derivative with respect to the x 0, the derivative with respect to the y is going to be 0. So that's what we're going to assume that g equal z minus g of xy. That means z minus 25 minus x squared minus y squared. So distribute the negative sign, so it's going to be z minus 25 plus x squared plus y squared. The gradient over g is going to be the derivative with respect to the x, 2x, the derivative with respect to the y for this one. The derivative with respect to the x is going to be 2x, the derivative with respect to the y is going to be 2y, for the z is going to be 1. That means the integral with cf dr is going to be the double integral with s equal f dot product with n ds and equal ff dot product with the grind of g dA. That's what we're gonna work on. So next step, we need to find the integral. So here's the core of f and here is the grind of g. We have to do the dot product. So it's going to be 8x squared minus y, 8y squared, and this one times also y, 2y, so it's going to be 8xy, 0 times 1 is going to be 0 plus 0. Because when you multiply this one with this one as a dot product, you have to distribute with this one. So the 2y times negative 4y is going to be negative 8y squared, and 2y times 4x is going to be 8xy. Then we're going to convert everything to the polar coordinates. I'm going to take the 8 as a common. For the x is going to be r squared cosine squared theta minus, take the 8 as out, it's going to be r squared sine squared theta plus r squared cosine theta sine theta, r dr d theta. So take the r squared as a common out, and times by r is going to be r cubed, and here's what's the left here, cosine squared theta minus sine squared theta plus cosine theta sine theta dr d theta. Now everything here is cosine 2 theta. For this one, we already know cosine, so sine, I'm gonna work with the cosine. Sine 2 theta is equal to sine theta cosine theta. Divide both by 2, so it's going to be sine 2 theta over 2 is going to be equal sine theta cosine theta. So sine cosine theta sine theta is going to be sine 2 theta divided by 2, dr d theta. Now let's do the integral with respect to the r. So it's going to be r to the power 4 divided by 4 from 0 to 5, and everything here is a constant. So simplify this one is going to be 2, and plug in the 5, so it's going to be 2, 5 to the power 4 minus 2, 0 to the power 4. This is cancelled, and here is the constant, so it's going to be 1250, and the integral for the left over here, which is cosine 2 theta plus 1 over 2 sine 2 theta. We're going to let the u equal 2 theta. That means du is going to be, let u equal 2 theta. That means du is going to be 2 d theta, divide both sides by 2. So d theta is going to be du over 2. So plug in the u here, plug in the u here instead of 2 theta, and d theta is going to be du over 2. Take the 2 out. So 1250 divided by 2 is going to be 625. The integral for the cosine is going to be sine. The integral for the sine is going to be negative cosine. Take the negative out, so it's going to be negative half cosine 2 theta. Bring back the u as a 2 theta. And now we're going to plug in 2 pi. So it's going to be sine 4 pi minus half cosine 4 pi minus sine 0 minus sine 0 minus half cosine 0. And this is 0 minus half minus, this is 0 minus half. It's going to be negative half plus half, which is 0. That means 625 times 0, and the result is going to be equal 0. So the result for example 6 is going to be 0. And that's what we're going to do with example 5 and 4. We got right. So let's move to example 7. We're going to do exactly the same steps. But now we have after the x, y, z equal x squared, z squared, negative x, y, z, and z equal the square root of 4 minus x squared minus y squared, which is the top half of the sphere. So an xy plane, it's a circle, it's a sphere. In fact, we're going to take only the top part on the positive side, which is between here's x and here's y. This is the negative y. So this is the y. So we're going to take only the top part, is going to be from the r is going to be from 0 to 2, and the theta is going to be from 0 to 2 pi. So the curl of f is going to be x squared, z squared, and negative xyz. The derivative with respect to the y, so it's going to be negative xz, minus the derivative with respect to the z is going to be negative 2z. For the j, is going to be the derivative with respect to the x is going to be yz. Negative yz is going to be positive. The derivative with respect to the z is going to be 0. That's why we have positive yz. And for the k, the derivative with respect to the x 0, the derivative with respect to the y is going to be 0. So we have 0. So we're going to let g equal, because it's counterclockwise. So z is going to be g equal z minus the square root of 4 minus x squared minus y squared. That means g equals z minus, we're just going to convert this one from radical to rational exponents. Then the grind of the g, we're going to find the derivative with respect to the x. With respect to the x, it's going to be negative half, because there is negative sign here. So negative half, everything with minus negative exponents times the derivative of inside, which is negative 2x. And for the y is going to be also negative half, everything to negative half times the derivative with respect inside, which is negative 2y. And the last part for the z is going to be 1. Now, next step, we're just going to simplify everything here. Negative with negative is going to be 1. So it's going to be just the x, and here is going to be just the y. And here is 1. Now, let's convert this one to the polar coordinates. So this is r cosine theta. This is 4 minus, this is the r squared. The same thing here, r sine theta. And here is going to be 4 minus r squared to the negative half, and here is 1. So it's going to be r cosine theta over square root of 4 minus r squared, and r sine theta over the square root of 4 minus r squared, and 1. That means the integral with f dr is going to be curl f to the product with n, curl f times the gradient of g dA. We already know r between 0 and 2, and the theta between 0 and 2 pi, and z equal 4 minus r squared. So now we're going to work on the last part, which is curl of f dot product with the gradient of g dA. So here is the curl of f, and here is the gradient of g, r dr d theta, because dA now is going to be r dr d theta. Depends by Jacobian. So from 0 to 2 pi, from 0 to 2, we're going to do the dot product. So this one times this one, you're going to cancel the root, 4 minus r squared. So the left is going to be negative r squared cosine square theta, minus, because minus this one times this one cancel. So it's going to be negative 2r cosine theta. Now the second part with the second part, cancel the root. So it's going to be negative, just r squared sine square theta, 0 dot product with the 1 is going to be 0. R d theta. Next step, we're going to distribute the r. So it's going to be negative r cubed, negative r squared, and here's r cubed. And let's find the integral with respect to the r. So it's going to be negative r to the power 4 over 4 cosine squared theta. minus 2r cubed over 3 cosine theta plus r to the power 4 over 4 sine square theta from 0 to 2. Plug in the 2, negative 16 divided by 4 is going to be negative 4 cosine square theta, and negative 16, plug in the 2 is going to be 8 times 2, 16, negative 16 over 3 cosine theta, and 4 sine square theta d theta. Now this part with this one, I'm going to take negative 4 as a common, cosine square theta minus sine square theta minus 16 over 3 cosine theta. This one is going to be cosine 2 theta, and keep this one as the same. Now next step, I'm just going to distribute the integral. And for this part, we're going to let u equal 2 theta. So du is going to be 2 d theta, du over 2 is going to be d theta minus 16 over 3. We can take the 16 over 3 out, and cosine theta d theta. So plug in the u here, du over 2. Take the 2 out, is going to be negative 4 over 2. The integral of cosine is sine, and the integral for cosine is going to be sine. From 0 to 2 pi, the same thing here. Let's plug in negative 2 here. Then it's going to be sine 4 pi minus sine 0, and 16 over 3 sine 2 pi minus sine 0. So now it's going to be negative 2 because this one is 0, 0, and 0, 0. So it's going to be negative 2 times 0 and 16 over 3 times 0. That means our result is going to be 0. Let's check that. Got it right. That's it for section 15.8.